All right, so this is Roman numeral 3, terrestrial biomes. So part 2 of this chapter 18 lecture. So on land, these terrestrial biomes, the number one dictator, right, predictor of what the climate or the biome is the climate. Sorry, the number one, predictor of the biome is the climate. What climate do you have? And by climate, right, we mean kind of like the weather. And the weather is dictated by the temperature and rainfall. So take a look here. We're going to go through the different, so you see the list of different biomes here. We're going to go through each one. And this is kind of just a pretty picture of where you find all those different kinds of biomes. And you can see that if we try to locate California, Los Angeles, here we are in blue. So we have a chaparral. We live in a chaparral biome. And if you look for other areas in blue, right, we have everything here along the Mediterranean Sea, a little tip of Africa, and also in Australia. So not a whole lot of the planet has the same kind of biome we have. So if you ever see pictures of people in Greece or in the south of France or, this upper African area, Italy, Spain, a lot of it looks like California. If you go to Malibu, sometimes, I had visited Greece recently, and sometimes you just think you're in California. So it's really, really similar. All right, so what affects climate? So these are the two major factors that affect climate: temperature and rainfall. All right, so we know that the temperature is dictated by how much sun an area gets, right? Because the more sun there is, the hotter it is. And if we look at this picture, the sun, it strikes the earth unevenly. It strikes the earth most directly at the equator, which is why the equator is the warmest part of the planet. It also strikes the earth for longer hours of the day. So because of the tilt and because of the rotation, the sunlight here never changes. So they have 12 hours a day of sun, 365 days a year. Whereas we, in the other zones here, we're going to be experiencing shorter days in the winter, longer nights, longer days in the summer, and not as strong and direct as the equator in terms of the solar radiation we get. And then we're going to have the poles. So the poles are going to get the most oblique or indirect sunlight coming at the poles, and so they're going to have less radiation. So that this tilt of the planet, right, this is what's going in that way that the sun strikes the earth, that dictates how much sun and the heat, but also it dictates the moisture. So this is how, and you don't need to know all the I'll tell you exactly what you need to know. So here at the tropics, right, this is the equator of the planet. You have the most direct sun, so the sun's coming down here. Because there's so much evaporation from that direct heat, the moisture goes up. Okay, so there is an upward motion for the moisture from the earth. The moisture in the air makes clouds, right? And of course, clouds, when they get too heavy, they'll release that moisture as rain. But clouds, funny enough, right? This is how moisture travels in the air, right? Clouds they're basically water vapor puffs, and they can move with the wind to different areas of the planet. And so they can actually, that's one way that water travels around the planet is through clouds. So there's an upward motion of moisture and air ascending from the tropics. Maybe you've heard of the word doldrums before, but this is where there's no wind. So because wind doesn't move laterally here, it doesn't blow left or right, or east or west, it goes up. So the doldrums mean that there's no wind. It's not windy because the air is drawn up. You do get wind later in the other parts of these temperate zones here. And those are called trade winds, and you might have heard that one before. And they are very consistent. And the reason why they're called trade winds is because sailors used them for trading routes because they were so consistent, and they blow in one direction. So anyways, but the trade winds, the doldrums, all this, the wind pattern on the planet is because of the way solar radiation hits the Earth. So if you take a look at the primary, the climate is determined by temperature and rainfall, okay? That's what determines the climate. So we're going to talk about other things that determine climate, but those are the two big ones. So I mentioned that heated by the direct rays of the sun, the air at the equator rises, then cools, forming clouds and drops rain. This largely explains why rainforests are concentrated in the tropics, all right? And so the region from the Tropic of Cancer to the Tropic of Capricorn. Okay, so here's our Tropic of Capricorn. Here's our Tropic of Cancer. This is where we're going to find a lot of rainforests because we have this scenario. You have a lot of evaporation, but it comes back down. All right, so temperate zones in pink. So we live in a temperate zone, right? They generally have milder climates than the tropics or the polar regions, all right? And they're between the tropics and the Arctic Circle and the tropics and the Antarctic Circle. So basically these pink areas here. We, of course, are living in the temperate zone. So what other factors can affect climate? So climate can be affected by the proximity to a large body of water. So I talked about this at the beginning of the semester where if you live in Venice Beach or in Santa Monica, you have a pretty consistent, pretty mild temperature all year. But if you live in the desert, in Joshua Tree, you're going to get wide fluctuations from day to night, right? If it's in the middle of the day, there's no water to absorb that extra heat. So the heat is very intense and the air gets very hot and the land gets very hot. At night when the sun goes away, it drops. There's no body of water to release that heat. So the temperature drops dramatically and it's very cold. Being close to a body of water mediates your climate. So it makes your climate, it doesn't give those wide swings because water can absorb heat when there's too much. It can release heat when it's cooling down. All right, and the presence of landforms, right? So mountain ranges, for example. So mountains are really important when you talk about climate because there's two things about a mountain. Number one is elevation, obviously, right? As you go up the mountain, the temperature drops and you can actually have several different biomes moving up that mountain. So let's take a look at this picture, right? You might have experienced this yourself if you're a hiker and you start off low and you're hiking up a mountain. When you start off, you might be in the desert or very desert-like environment or biome, or maybe you're in a desert grassland. But as you move up in elevation, you're going to start to see the plants change, right? You might hit an oak woodland, then you might hit a pine woodland, then you might hit a spruce fir forest, right? And then way, way up here, there's something called mountain tundra where nothing grows. But very different kinds of environments as you go up in elevation because you have big temperature changes because of that elevation. Another factor that mountains give you is this rain shadow effect. So I have a picture of this in your outline. So the rain shadow effect is that one side of the mountain causes a block in moisture to the other side. So you can see here that here's our Pacific Ocean. Here is a coast range. So we have moisture, right? The ocean water will evaporate to the sky, forming clouds. The clouds will move over the earth. But then sometimes a mountain will block that passage. And so one side of the mountain gets the wet rainfall and the other side of the mountain does not. So this side is going to be a desert. But it's because it's it's not allowing the rain to come in. So it's called a rain shadow desert. And what really cool picture here is the rain shadow effect here in California. Notice right here, this white, that's the top of our mountain range. Look to the ocean side, we have greenery, right? So all this part is green, 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 green. And the other side of the mountain, desert, 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 right? So that's a really cool picture of the rain shadow effect in California. All right, so we have talked about the terrestrial biomes and what really dictates or the big significant factors of a terrestrial biome are climate, which is predominantly temperature and rainfall, and then what kind of landforms you have. Big bodies of water or mountain ranges really help, not help, but they really dictate what kind of biome you are in. Okay, now we're going to run through them. Okay, so the tropical forest, we're going to start at the equator and then we're going to move towards the poles. So the first one on the list is the tropical forests. Okay, so tropical forests, you may already have an image of this in your mind. They occur in our equatorial areas where the temperature is warm and the days are long, right? So 11 to 12 hours of light all year round, which I think is lovely. Because there's so much light, it can support a lot of photosynthesis, and you're going to have plants at every single layer of that can exist. So you have plants at the bottom, on the ground, you have middle shrubs and smaller trees, and then you have really tall trees that form a canopy. So the treetop ecosystem, or the niche, so I'm going to use the word niche, N-I-C-H-E, or sometimes people say niche, but this is an area within a biome that certain animals occupy. So the treetop is called a canopy, and some animals will only live in the canopy, and they never come down to the forest floor. So food is very abundant in trees, and so these animals don't have to leave the treetop if they want to stay there. They have everything they need in the treetop. One thing to remember is that there are actually two kinds of tropical forest: tropical dry forest and tropical rainforest. The only difference is, like, obviously a tropical dry forest doesn't get as much rain. It still gets rain, but it's not as long. It has a longer dry season. Tropical rainforests get a lot of rain, 13 feet a year. And tropical rainforests is where biodiversity is the greatest. So you get the most diverse, right? So very many different kinds of species of plants, animals, fungi, etc. Here. Okay, so the loss of tropical rainforests is a huge loss because scientists haven't even found, right? There's still species and living things that we need to discover, plants and animals and all different kinds of things. And we are learning a lot from these plants and animals, and sometimes these plants have chemicals in them that we can use to treat illnesses or treat infections. Natural kinds of antimicrobials can be found here, but with their destruction, we're losing the chance to maybe discover this, what secrets that they have in the tropical rainforest. So it's really sad. So here is our tropical rainforest, and I'll put this clip either in your lab exercise or in the module. Next is up savanna. So savannas are marked by grasses and scattered trees. It's warm year round, right? It's you have some rainfall. You have seasonal variation, so there's a wet season and dry season. Fire is an important factor in savannas. Some plants have been so adapted to fire that they sprout very quickly after a fire. The reason why savannas have just a few trees here and there is because the soil doesn't have a whole lot of nutrients, and also the moisture is pretty low here. You have a lot of grazing animals in the savanna. I'll put this link in your lab. And then lions and cheetahs, and then the Australian savanna will have kangaroos in it. All right, the desert. Oops, so here's a picture of the savanna. The desert does not have to be hot. So the definition of a desert is dry. It's the driest of all the biomes. It has very low and unpredictable rainfall. It can be hot, like Death Valley, or it can be cold, like the Mongolian desert, right? So we just have to think about deserts as being dry. Because deserts are so dry, the plants and animals that live there have adapted. They have very special adaptations to storing water. And I will put these also in your lab exercise so you can take a look at those videos. This saguaro cactus is really cool. The pleats on this cactus is basically just extra tissue so that when it does rain, it sucks up all the water it can and those pleats expand. They allow the cactus to expand, and then you'll have a cactus that is all bloated without the pleats, and then as it uses its water, it will start to become pleated again. All right, a chaparral. Oh, here's another picture of a desert. The chaparral. So this, if you look at this picture, right, this could be Malibu. It could be anywhere. I keep saying Malibu. I don't really go to Malibu that much, but or ever. But the chaparral is a climate that results from being next to an ocean. So if you remember that picture I showed you, I said here's Los Angeles and then the Mediterranean Sea. All of that is right along a big body of water, the Australian coast along a big body of water. So this being along a big body of water is important because it results from the ocean currents. So you're going to have mild rainy winters and hot dry summers. So that's pretty typical of where we are. This is also called a Mediterranean climate because it's around the Mediterranean Sea. In chaparrals, you have a lot of fruit producing, berry producing kind of shrubs. So you have fruit eating birds, you have some deer, they're adapted to some fires. And should say also that this chaparral is also called a shrub forest. And then here's the chaparral. So again, let's just take a look, right? There's a little brown here, there's brown here, here, and here. All right, this is Malibu. All right, the next biome we have is a temperate grassland, otherwise known as prairie. And so I have it listed as prairie in your outline. Prairies are treeless, so it's just all open pasture. And so it's treeless. There are some droughts and fires. There are a lot of grazers, so you're going to have grasses. So you're going to have things like bison and pronghorn sheep. And so grazers are going to keep those shrubs from growing. They're going to eat the grass as it grows. And then the soil in prairies is actually really, really fertile. So as a result, we're taking a lot of our pasture grasslands and converting them to farms, to cropland. So there's very little natural prairie left in the United States. We've used this land to make huge, huge farms. So here is a nice grassland with a bison, and take a look at where we find this, right? So if this is the United States, this is the Midwest. And if you think about the Midwest, you think about, this is sometimes called the wheat belt because they grow a lot of wheat and corn, a lot of farmland, right? So you think about Kansas, and you think about like all the farms in the middle of the United States. So this is kind of like this region, right? So it had a lot of prairie being converted into farms. All right, so I wanted to show you here, this is just another illustration of what I was talking about. Percent of land area devoted to farming. So the darker the green is the more land converted to farming, and the lighter the green the not. So you also see like Central California, right? We know that we have a lot of farms here too. So you can see the dark green in Central California. But this is really dramatic showing of that overlap with the prairie land, right? So because the earth was so fertile. Okay, next one is our temperate broadleaf forest. So this one is going to have your moisture. If you're from the East Coast or have ever visited the East Coast, this is basically your East Coast forest. So you have large trees, you're going to have a lot of dense trees. They're deciduous, meaning that they lose their leaves. And when they lose their leaves, you're going to create something called leaf litter. So you're going to have, just think about walking through these forests with a lot of leaves on the ground. You have a lot of, it's like a soft ground almost because of all the leaves that have fallen off every year. And mammals can use this to survive or live in or hide their acorns or whatever. So mammals will hibernate in this broadleaf forest. Hibernation is common. Right now, they're using a lot of these forests to log So they're clearing them for agriculture and for the wood, basically to build your home, right? You need wood, pine, things like that. So that is our temperate broadleaf forest. So this is a picture of that broadleaf forest right before the leaves fall, right? So this is the fall in these areas. Take a look at where we find our temperate broadleaf forest, right? East coast of the United States. So really beautiful fall weather out there. All right, our next one is coniferous forest. So again, cone-bearing trees, right? Conifers. So if you take a look, these are a lot of, well, you can't really tell, but there are a lot of pine trees. There are two huge areas. There's the northern coniferous forest, otherwise known as the taiga, the largest terrestrial biome on Earth. So this is it, starting from here all the way over across the planet, right? So all this is that northern coniferous forest. And then there's a temperate rainforest from Alaska to Oregon. There's redwoods there, Douglas fir. Those two are heavily logged for their wood. And then here is our coniferous forest. So this is basically what you picture when you picture Christmas time. Pretty northern latitude here, right? And that's about it. So in your notes I have that they have cool, it's very, can be cold. They have high elevations, snowy winters, short wet summers. Moving up even higher now, we have the tundra. Oh, California redwoods. So this is going to be a coniferous forest in California. The tundra is an area that is super cold, and it covers large areas of the Arctic Circle between the taiga and the polar ice caps. And one of the hallmark traits of the tundra is the permafrost. Permafrost is permanently frozen subsoil. So it's not the top of the soil, but it's underneath. And the top would freeze and thaw with the seasons, but the permafrost is permanently ice. And the winters are very, very cold. There's a lot of winds. There's no large plants here because it can't sustain the winds would just knock them down. And in the summertime, I have a picture of the summer, there's small plants, right? So small vegetation that grow, and then you have animals that will eat the moss and the lichen, the small vegetation. There is something called the alpine tundra, which is if you go high enough on a mountain, it gets cold enough and and it gets windy enough that you lose the tall trees. And so you call that the alpine tundra. But it's different than the actual tundra because there's no permafrost. Okay. So I do have a list here that the permafrost is melting with the global warming, right? And so they are looking at what's happening and how that's going to change the ecosystem if they find that what happens when the permafrost is no longer permanently frozen. All right, so the polar ice caps is the very tips or poles of the planet Earth. They are very cold, right? Full, and they're covered with ice. So the polar ice covers the land. It's in the Arctic and in Antarctica. So there's only two places that have polar ice. Only a small portion of these land masses is free of ice or snow, even during the summer. Of course, this is changing. This scene that you see here where large sheets of ice are just falling into the ocean, this is very common now because we know that the polar ice caps are melting. And when they melt, it will change the sea level, right? The sea level is going to rise, and that's going to cause flooding and a lot of different kinds of changes. So these polar ice, another sort of sad thing is that these sea ice are feeding platforms for penguins and polar bears and seals. Sorry, I can't speak today. But here's a couple of polar bears, and you see how they're standing on this block of sea ice. So they'll hunt and they'll get tired and then they'll come onto the sea ice to take a rest. But polar bears are actually excellent swimmers, but if they swim too far away and they don't have any sea ice, then they could drown from just being exhausted. And they have found some polar bears drowning because they don't have sea ice to rest on anymore, which is incredibly sad. So how does climate change affect this biome? I will put this up in your lab so you can take a look at that as well. Okay, and this is our polar ice. So you can see the two poles here. All right, so we'll stop this and we'll pick this up in the third part.